Hi guys, my name is Miss Jakes. I'm one of the Algebra 1 teachers at Bristol Eastern. Some of you guys who are watching this video were in my class this year, and the other of you guys were in Miss Leski's class, so I just wanted to explain who I am. What we're going to do today is we're going to recap lessons 1 through 4 that we did in the last 2 weeks. I know some of the topics were a little bit difficult for some of us, so we're just going to review those topics, and then we're going to do problems right within the form. So what you'll do is you'll watch this video, and then you'll do the problems for simple interest, and then so on throughout all of the topics. Okay, so let's get started. So the first thing that we learned way back on April 20th and 21st was this formula called the simple interest formula. And the simple interest formula is a way to calculate how much interest you get in a bank account based upon the initial deposit, the initial amount of money that you put within that bank account. Okay, so they gave us this formula and they gave us all these letters and they told us what these letters stood for. So when we see the P of T, that's the account balance after T years. That's our answer. So after we plug in all of the numbers in for these variables over here, we're going to get P of T. We're going to get our answer. P of 0, P sub 0, is the initial account balance at 0 years. So that's how much money they put in right at the beginning. So in the problem below, you see Jackie invests $6,000. $6,000 is going to be our P of 0. That's going to be our initial investment. The R is the interest rate. And this is where it gets a little bit tricky. This is where I saw the most errors. The interest rate has to be written as a decimal. So if you look in the problem below, we've got like 3.25%. That's a percent. So to change a percent to a decimal, you need to move the decimal place to the left twice, or you have to divide by 100. So if we had, for example, like 5%, what you would do is you would assume there's a decimal here and you move it over 1, 2, so you'd get 0.05. So when we do this problem down here, we're going to have to do the exact same thing. We're going to have to change that percent to a decimal. And you have to do that with whatever kind of formula you're working with in this unit. The simple interest, you'll see it happen again in the compound interest. You're going to see it in exponential growth and exponential decay. It's really, really, really important that you turn that R value to the decimal. Okay? And the last letter we see right here is the T. And just like in a lot of the other formulas that we saw throughout the year, T is going to stand for time. If we're not given the time and they're asking us to do a general formula, we just leave that T there. But if they tell us to solve for after a specific amount of time, that's when you're going to be putting the number in place of the T. You guys ready to do a problem? Cool. Okay. So this problem says Jackie invests $6,000 into an account that earns 3.25% simple interest each year. Okay, so we've got some information here. We've got the $6,000. That's the initial amount that she's putting in the bank account before anything else. So that's going to be our P of 0. And you don't have to go and write these on top of the numbers, but sometimes it helps me so that when I go back to the formula, I know where I'm putting things in. We've got the 3.25%, and that again is written as a percent. So we're going to have to put it as that decimal because it's really important that we put things as decimals. So I'm going to take that decimal place, I'm going to move it to the left twice. Or I'm going to take 3.25 and divide it by 100 in my calculator, whatever I want. And I get 0.0325. Some of you are probably wondering why we have to do that. If you forget to do that and you put in 3.25, you're going to get a huge number, which would be amazing if our bank accounts grew that big so quickly. But it doesn't happen that way. It's just going to give us a number that's going to be way too big. Okay, use function notation to represent his account balance as a function of time. So because the formula right here says P of t, I'm just going to use P of t, P sub t. Function notation, like we saw at the beginning of the year, was f of x or f of t. But just to stay consistent with the formula, I'm going to follow what they have here. Equals the initial amount. So we said that's 6,000. So I'm going to say 6,000. Okay. Plus parentheses P sub 0. So that's still 6,000. And then we've got this dot, which means times. So times. And the R value right here is, I'll do a 0 in front of it just to make it look good. 0.0325. Close the parentheses. And we're just writing a function here. So we're not putting in anything for t because we're just going to leave it like that. So that's our first step, is to figure out what the formula is. And you're literally just taking the numbers from the problem and following this formula exactly as it is. If the problem says simple interest, that's your formula. It doesn't change. It will always be that formula for simple interest. So our next question says, is this a linear or an exponential? So you won't see this question on today's form, but it was a question that we had to do when we first did this lesson back on the 20th and 21st. So what we need to look at is we need to look at where the variable is located. And the variable in this function is t. So if I look at this t, I'm going to just use my highlighter tool real quick. If it loads. Okay. My t right here is at the exact same level of these numbers. So it's at the same level. That means that it's going to be a linear equation or a linear function, because you're taking a value and you're doing a number times t. So really, this is kind of interesting. This right here, this 6,000 is our b, it's our y-intercept. And this right here, 6,000 times 0.0325 is our m, it's our slope. You're not going to be asked about that, but that's how that is set up. That's a linear. And just so you know, all simple interest equations are linear. So if you ever see that question again, simple interest, linear. Okay, our last part is to use the function that we created to calculate the account balance after 13 years. So years is time. So what I'm going to be doing is I'm going to be putting that 13 in where the time is. I'm going to move this over here so I can move my page a little bit. That's a little too much. Okay, so I'm going to take this and I'm going to say P of t, because I still don't know what my answer is, equals 6,000 plus parentheses 6,000 times 0.0325. And this time, instead of putting t there, I'm going to put a 13. So I'm going to put the parentheses around it. You don't have to do that. You could just do times 13 if you prefer. I'm putting the parentheses to make it look nicer. If you have one of the TI graphing calculators, you're just going to take that and you're going to type that all into the main screen. If not, what you're going to do is you're going to go into Desmos, which I opened here, and we're just going to type that in. So 6,000 plus parentheses 6,000 times, and I used the Shift 8 to use a little star to get that times, but you can also use, there's going to be something down here, not this, this is what I'm using to do the screencasting. There'll be a little button here with like some keyboard stuff, and you can click on that and it will allow you to choose times or whatever you want. 0.0325, close it, and we said we're looking for 13 years. And just press enter, and my answer is right here, $8,535. So I'm going to go back here, and I'm going to say it is 8,000, comma, and I forgot already, $535. $535. And that's it. That's how you do a simple interest. So remember, you are going to first start by writing the formula based off of this right here, identifying the initial amount and identifying the rate. And then you're going to use that formula to plug in the time to get a final answer. If you're still stuck with simple interest, make sure you reach out to either Ms. Selesky or I, and we're going to help you out. Talk to you soon when we talk about compound interest.